Welcome back. Chapter 7, Section 7.4 Sampling Distributions. Focus points. Review such commonly used terms as random sample, relative frequency, parameter, statistic, and sampling distribution. From raw data, construct a relative frequency distribution for X bar values and compare the result to a theoretical sampling distribution. Let us begin with some common statistical terms. Most of these have been discussed before, but this is a good time to review them. From a statistical point of view, a population can be thought of as a complete set of measurements or counts, either existing or conceptual. So that's a population. A sample is a subset of measurements from the population. For our purposes, the most important samples are random samples. When we compare a descriptive measure such as an average, it makes a difference whether it was computed from a population or from a sample. A statistic is a numerical descriptive measure of a sample. So the measure that you get from a sample is called statistic. On the flip side, the measure you get from a population is called a parameter. Some commonly used statistics and corresponding parameters. Mean. For statistic, you designate it by X bar. X bar. All right, that bar is the overline. Parameter is mu. This is a Greek letter mu, mu. So mean in a sample is called X bar. In a population, it is called mu. Variance. In a sample, it's called S squared. In a population, it is called sigma squared. Because it is in a population, it is a parameter. Standard deviation. In a sample, it is S, which is statistic because it's from a sample, and sigma is a parameter because it is from a population. Proportion. It is P hat and P here. All right. Often, we do not have access to all the measurements of an entire population because of constraints on time, money, or effort. Often, what this means is, look, we are making a statistical study. Our population might be very large. So we might not be able to get information about the entire population. So we use measurements from a sample instead. In such cases, we use a statistic such as X bar, which is the mean, S, which is standard deviation of your sample, or rho hat, which is proportion for your sample, to make inferences about a corresponding population parameter. So using this, we will make inferences about the population parameter, be it mu, sigma, or P, corresponding mean, corresponding standard deviation, corresponding proportion. The principal types of inferences we will make are the following. One is estimation. In this type of inference, we estimate the value of the population parameter. So from our sample information, we are estimating value. Testing. In this type of inference, we formulate a decision about the value of the population. So a decision, first a value, then a decision, okay, for the purposes of testing. Regression. In this type of inference, we make predictions or forecasts about the value of a statistical study. To evaluate the reliability of our inferences, we need to know the probability distribution for the statistic we are using. Such a probability distribution is called a sampling distribution. Okay, sampling distribution. Example 9 that's coming up will help clarify this discussion. A sampling distribution is a probability distribution of a sample statistic based on all possible simple random samples of the same size from the same population. So, say you have a certain population, you want to find its mean. Okay, you have a population, you want to find a certain measure and find the mean of that measure. You start taking samples and finding the mean of each of those samples. So the samples are simple random of the same measure. So you take many samples and take take the same of the same size and then find, for example, if I want to find the mean income of 500 households, well, I will not be able to go to each and every household. So I will send out my friends, say. Pretend I have 10 friends. Each friend takes care of 50 households. So for each friend, the friend gives me a mean of their sample. So I have now 50 means. That is an example of a probability distribution of my sample statistic. Let's look at an example. Pinedale, Wisconsin is a rural community with a children's fishing pond. Posted rules state that all fish under 6 inches must be returned to the pond. Only children under 12 years old may fish, and a limit of 5 fish may be kept per day. Okay, so a child is allowed to fish. Children under the age of 12, they are allowed to fish. And each child can take only 5 fish a day. Susan is a college student who was hired by the community last summer to make sure the rules were obeyed and to see that the children were safe from accidents. The pond contains only rainbow trout and has been well stocked for many years. Each child has no difficulty catching his or her limit of 5 trout. As a project for her biometric class, Susan kept a record of the lengths to the nearest inch of all trout caught last summer. Hundreds of children visited the pond and caught their limit of 5. So Susan had a lot of data. So Susan selected 100 children at random and listed the lengths of each of the 5 trout caught by a child in the sample. Okay, so Susan is now looking at a sample of 100 children. Okay, all right. 1 through 25, that is the sample. So there are 100 children. So she has 25 here and 51 here. That makes no sense. 26 to 50 here and so on. All right. So she has 100 children. Now each child has caught 5 fish. For example, here is child number 95. The first fish the child caught was 11 inches long. Second one was 11 inches long. Third one is 9 inches long. Fourth one is 9 inches long. Fifth one is 9 inches long. The average length for child number 95 is 9.8. All right. And so on. 91st child had 5 fish. Average length is 9.0. So While the length of each fish has been listed, what is our Susan doing? She is calculating the mean for each child's number of fish. Okay? Notice every child has 5 fish. So the sample size for each child is the same. Now, she is going to use these numbers, that is the mean numbers, rather than individual fish numbers. So she is collecting the sample mean from every child and going to do something with them. Then for each child, she listed the mean length of the 5 trout that the child caught. Now let us turn our attention to the following question. What is the average or the mean length of a trout taken from Pinedale Children's Pond last summer? We can get an idea of the average length by looking at the far right column of our table. Just looking at the 100 of x bar values doesn't tell us much. So what is the far right? That's the far right. Okay. For each child, you have x bar. So x bar is the sample mean. So this is the average length of the 5 fish caught by each child. So just look at that. There is such a big variety of lengths, sample lengths. So we just by looking at those numbers don't tell us much. So